All right, today we are learning section 5-1. This lesson I think you're going to find to be pretty easy. We're just basically practicing some vocabulary with a little bit of math, but nothing too hard. Okay, so first of all, something is quadratic if the highest exponent is a 2. Something is linear if the highest exponent is a 1. Okay, so with a little vocabulary, if something is quadratic, we have these different terms. So the quadratic term is everything that is smushed with the x squared. The linear term is everything that's smushed with the x. And the constant is just the number that doesn't have the variable attached to it. So a constant is just a plain number. The linear term is what's smushed with the x, and the quadratic term is what is smushed with the x squared. Okay, so first thing we have to do down below is decide if something is linear or if it's quadratic. So if the highest exponent is 1, it will be linear, and if the highest exponent is 2, it will be quadratic. So that's the first thing we're going to do. And then we're going to identify the different pieces. We're going to identify the quadratic, linear, and constant terms. Okay, and some of the problems we'll have to simplify before we can begin. So looking at number 1, you don't even see an exponent, which means the highest exponent is a 1. So whatever the highest exponent is determines what it is. So since the highest exponent is a 1, this is linear. And then I'm going to label my terms. So I've got my quadratic term, I've got my linear term, and I've got my constant. Okay, so the quadratic term is anything smushed with the x squared. Well, because there is no x squared in this problem, then there's no quadratic term. So I'm just going to write none. You could put 0 if you wanted, so I'll put none or I'll put 0. The linear term will be anything smushed with the x. So the only thing that's smushed with the x is a 1. You just don't see it, so either 1x or just x. And the constant is the number that doesn't have a variable behind it. And so our constant is just this plain looking number back here, which is a positive 4. And if it had said -4, then I would have put -4. And that's my answer, and I'm done. Pretty easy. I think you'll like this lesson. Okay, this one. The highest exponent is a 2. So when the highest exponent is 2, this is called quadratic. And then I'm going to label the quadratic term, the linear term, and the constant. So the quadratic term is anything smushed with the x squared, which is 2x squared. The linear term is anything smushed with the x, which would be -3x. And the constant is just the plain number that doesn't have a variable attached to it. So our constant is this -5 back here. Pretty easy? I think so. All right, the next one. The highest exponent is a 2, so this would be quadratic. And then we're going to label our terms, our quadratic term, our linear term, and our constant. So the quadratic term is anything smushed with the x squared, which is just x squared or 1x squared. The linear term is anything smushed with the x, but there's not just a plain x in the problem, so I'm going to put none, but if you told me 0, that would be fine too. And then the constant is just the plain number that doesn't have a variable attached to it. So the constant is -7. Okay, so basically those three were just kind of practicing our vocabulary. Now these next 5 all have some simplifying that we need to do. So remember, if you see parentheses, you need to distribute to get rid of your parentheses. So I need to take 3x times x and 3x times -2. So 3x times x makes 3x squared, and 3x times -2 makes -6x. Now, if I could combine those, I would combine them, but you can only add and subtract things if they look alike, and these don't. This has an x squared, and this just has an x. So that's as good as it gets. So now I'm going to do what I did above. Since the highest exponent is 2, then it's called quadratic. And then I'm going to label my quadratic term, my linear term, and my constant. So the quadratic term is anything smushed with the x squared, which is 3x squared. The linear term is anything smushed with the x, which is -6x. And the constant is the plain number that doesn't have a variable behind it, and you don't see that. So you could either put none, or you could tell me 0. I'd be happy with either answer. Okay, this next one. You have 2 sets of parentheses smushed together, which means I need to multiply everything in this set of parentheses with everything in this set. So basically, I distribute the 2x first. So I take 2x times the x and 2x times the -4. And then I have to distribute the 3. So I have to take 3 times the x and 3 times the -4. So I think of this as double distributing. So first you distribute the 2x with everything in the back, and then you distribute the 3 with everything in the back. Okay, so here we go. 2x times x makes 2x squared. 2x times a -4 makes a -8x. Now let's distribute the 3. So 3 times x makes 3x, and it's positive, so put plus 3x. And 3 times -4 makes -12. Okay, and then if you ever have like terms, you want to combine them, and we do. These guys in the center both have an x, so that means I can combine those. So the 2x squared is just going to come down, and I just ask myself, what's -8x plus 3x, and that's a -5x. And then the -12 just comes down. And that's my answer. Okay, but now I've got to do all the vocabulary stuff on it. So linear or quadratic, what do you think? Quadratic! The highest exponent is a 2. Okay, and so now I'm going to label the quadratic term, the linear term, and the constant. Okay, so what do you think the quadratic term is? 2x squared. Very good. How about the linear term? -5x. Beautiful. And how about the constant? -12. Yes, and that's our answer. Okay, and then number 6. Now, you have to know what it means to square something. So you know how 2 squared means 2 times 2, 3 squared means 3 times 3? Well, 2x minus 1 squared means 2x minus 1 times 2x minus 1. So when you square something, you want to take it times itself. Okay, so now I need to distribute. I need to take the 2x times both things in the back, So let's just do that first. So 2x times 2x makes 4x squared. 2x times negative 1 makes a negative 2x. And now I need to distribute the negative 1 with everybody in the back. So negative 1 times 2x and negative 1 times negative 1. So negative 1 times 2x makes a negative 2x. And negative 1 times negative 1 makes a positive 1. And then do you see any like terms that you can combine? Yes, sirree, Bob. You can combine these guys in the center. So the 4x squared that's in the front will just come down. Now, a lot of people think this makes 0, but it does not. If it was a negative 2x and a positive 2x, that would make 0. But negative 2x minus 2x makes a negative 4x. Two negatives add together to make an even bigger negative. And then the plus 1 in the back drops. Okay, so now it's vocabulary time. Is this linear or quadratic? Quadratic. The highest exponent's 2. Okay, so now I want to label the quadratic term, the linear term, and the constant. So what do you think the quadratic term is? 4x squared. How about the linear term? Negative 4x. And how about the constant? Positive 1. So even though we've had to do a little simplifying, hopefully you remember how to do this from your past. Okay, now number 7, silly me, I wrote the exact same thing as number 6. So let's change this. Let's make it y equals 3x plus 4, quantity squared. Okay, so remember, when something's squared, it means take it times itself. So I want to take 3x plus 4 times 3x plus 4. And then I'm going to double distribute. So I'm going to take 3x times everybody in the back. So let's do that first. So 3x times 3x makes 9x squared. 3x times 4 makes 12x. Now let's distribute the 4 with everybody in the back. So 4 times 3x and 4 times 4. So 4 times 3x makes a positive 12x. And 4 times 4 makes positive 16. Okay, do you see any like terms that you can combine? Oh yeah, we can combine these x's in the center. So the 9x squared that's in the front will just drop down. A positive 12x and a positive 12x add to make a positive 24x. And then your positive 16 in the back just drops down. Okay, so now it's vocabulary time. Is this linear or is this quadratic? Quadratic. The highest exponent is a 2, so this is quadratic. I've kind of run out of room on this guy. Okay, so now I'm going to label the quadratic term, the linear term, and the constant. So what do you think the quadratic term is? 9x squared. How about the linear term? 24x. And how about the constant? Positive 16. Very nice. Okay, one last little problem to do. All right, so I've got 2 sets of parentheses, but they're not both smushed together. So it's not like the last 3. So this set of parentheses, I need to distribute the 3 times everybody in the parentheses. And then for the other set of parentheses, I need to distribute the negative 3 times everybody in the parentheses. Okay, so 3 times x squared makes 3x squared. 3 times negative 2x makes negative 6x. Okay, now distribute the negative 3. So negative 3 times x squared, it's going to give you negative 3x squared. Negative 3 times negative 2 gives you positive 6. Okay, do you see any like terms that we can combine? Yes, the x squareds. Okay, so what do you get if you combine 3x squared minus 3x squared? 0. The x squareds are gone. Whew, out of the problem. The minus 6x just drops down, and the plus 6 just drops down. Okay, so what do we have? Linear or quadratic? Linear. The highest exponent is a 1. You just don't see it. So this is linear. And then I'm going to label the quadratic term, the linear term, and the constant. So what do you think about the quadratic term? There isn't one. There's no x squared in the problem. So you could tell me none, or you could tell me 0. The linear term, negative 6x. And how about the constant? Positive 6. And that's our answer, and we're done. What do you think of this lesson? Think it was pretty easy? A little bit of computation, a little bit of distributing and combining like terms, but other than that, a little vocabulary, but pretty easy vocabulary. All right, that's all for this lesson. Smiley face.